Hi students, today we can discuss the next topic in the chapter metals and nonmetals. The topic is how do metals and nonmetals react? How do metals and nonmetals react? Okay, so before coming to that topic, we can discuss or we can find out why do metals and nonmetals react? Okay, to explain that or to answer that question, see, just observe the table given here. It is given the electronic configuration of few elements. So first three are noble gases. Okay, first one helium with atomic number 2 electronic configuration. K shell is having 2 electrons. That means that shell is completely filled. Now neon, atomic number 10, electronic configuration 2, 8. That means that first two shells are completely filled. The third one is argon, atomic number 18, electronic configuration is 2, 8, 8. That means the three shells are not completely filled but filled in a stable manner, stable state. Okay, actually the capacity of M shell is 18, but the state of 8 electron is a stable state. That means argon is also in a stable state. Okay, now let us see a few of the metals given. Sodium 281, magnesium 282, aluminum 283, potassium 2881, 2882 for calcium. Metals. Okay, now coming to non-metals, you can see it is 25 nitrogen, 26 for oxygen, like that. What is a speciality of metals, or how do metals and non-metals differ in their electronic configuration? Do you notice? See that in the case of metals, the last shell is having either 1, 2 or 3. Whereas in the case of non-metals, it will be having the outer shell. Okay, the outer shell will be having 5, 6 or 7, like that. That means metals with a less number of electrons, whereas non-metals with a high number of electrons. So how do they differ? So these metals, when they react, they'll be giving out this last shell electron. Or why do they do like that? Because they want or they wish to or that have a tendency to reach the noble gas configuration. For example, in the case of sodium, the electronic configuration is 2, 8, 1, right? So if it is giving out this last electron, 1 electron, or it is giving to somebody else in the sense some non-metal, it will reach a state of 2, 8. Okay, that means it is almost near to the noble gas 2, 8 neon. Okay, so sodium is trying to be in a state of neon, whereas this magnesium also, the aluminum also wanted to reach a state of neon. What is special about that state? It is a stable state. So metals and non-metals. In the case of non-metals, what happens? See, the first non-metal given is nitrogen with the last shell 5 electrons. Okay, so if it wants to be in noble gas configuration, reach a noble gas configuration, it need to get 3 more. Okay, so it will try to get 3 more electrons from a metal, and where in this case of oxygen, it will try to get 2 more electrons so that it reaches neon-like structure. Whereas this phosphorus will try to get 3 more, reaches a argon-like state. Chlorine also reaches argon-like state by gaining or by trying to get 1 more electron. Okay, so these all the non-metals want to get electrons, whereas all the metals wanted to give out electrons. Okay, that is a specialty. And why do they are giving out or taking in or gaining electrons? Because they wanted to reach a stable state, just like that of noble gases. So that is the reason why metals or non-metals react. Okay, so metals or non-metals react just to reach a stable state, completely filled a valence shell, just like noble gas configuration. Okay, now we'll talk about how do metals and non-metals react. Okay, first we'll talk of about sodium chloride. Okay, sodium, the electronic configuration is given, electron dot structure is given here 281. Last shell is having one electron. So what it is doing is to give out this electron and reaches Na plus like 2,8. Okay, Na plus sodium plus Na plus. Whereas what chlorine is doing, chlorine takes that electron, takes one more electron, uh, the sodium is giving out and reaches Cl minus state. Last it was having 7, now after gaining one more it reaches 8. So 2,8,8, whereas sodium with the 2,8. Now Na plus and Cl minus are stable state like noble gases, isn't it? So once they form this positively and negatively charged ion, they attract each other and form the sodium chloride crystal or molecule. Okay. See, it is showing in another way that formation of sodium chloride can be shown this way as well. Using symbols and all, here it is showing using symbols, here diagrammatically or with the electron dot structure it is showing. Okay, so Na is becoming Na plus, Cl is becoming Cl minus, both with the electronic configuration of noble gases. And once Na plus and Cl minus forms, they attract each other and forms a sodium chloride molecule. Okay, so sodium is gaining a positive charge, whereas chlorine is gaining a negative charge, right? That is how sodium chloride. So when a metal meets a non-metal, what is happening? Compound formation is taking place. Okay, due to ion formation. Okay, and the compound is called ionic compound because they are combining ions, or ions are combining to form the molecule. So the compound is called a ionic compound. Now, once again, more clearly it is showing in a picture sodium giving out the last electron to chlorine gains a positive charge, whereas chlorine gains a negative charge and thus forms a sodium chloride molecule. This picture gives you the clear idea, right? Now, we'll take another example of magnesium chloride. We'll have it out why MgCl2 is the formula, isn't it? That we will answer in this way. See, for example, magnesium atomic number 12, electronic configuration is 2,8, 2. It gives out the 2 electrons because it wanted to reach the noble gas configuration. Giving out 2 electrons gains a positive, 2 positive charge. Okay, whereas chlorine need only 1, so it will take 1 electron and Cl becomes Cl minus ions. But the problem is magnesium is having 2 electrons to give out, but one chlorine needs only 1 electron. So what it will do, it will find another chlorine and it will give the second electron to that chlorine and forms the compound called. So one magnesium needs 2 chlorine. That is why the formula MgCl2. 1 magnesium, 2 chlorine atoms. Okay. So that is how magnesium chloride is formed. One magnesium is ready to give out 2 electrons, but one chlorine need only 1 electron. So to need 2 chlorine to take in the 2 electrons. Okay, and the compound formed is called so magnesium chloride is another ionic compound. Why? Because magnesium ions and chloride ions are formed and they get attracted to each other and form the ionic compound. Another name is electrovalent compound. Okay, electrovalent compound. Now that once again it is showing in a more clear way. Mg with the 2 electrons giving 1 to 1 chlorine, the other to the other chlorine, forming the magnesium chloride molecule. Okay. Now sodium oxide. Sodium oxide, see sodium, we know last shell is having 1 electron. Oxygen is having 6 electrons in the last shell. Sodium with 1 electron, oxygen with 6 electrons. Okay. So sodium wanted to give out this 1 electron, but oxygen needed 2 electrons. So what will do? 2 sodium has to come to meet 1 oxygen. So 2 sodium give out one electron each to one oxygen atom, forming a compound called sodium oxide, Na2O. Okay, there Na plus and O2 minus, Na plus and 2 Na plus, okay, and 1 O minus, O2 minus will be formed, and the compound is Na2 sodium oxide. And see, coming to magnesium oxide, magnesium is having atomic number 12 with electronic configuration 2, 8, 2. Okay, so what it is doing, it is ready to give out 2 electrons, and we know oxygen need 2 electrons. So magnesium gives out the 2 electrons to that oxygen and forms magnesium oxide. So one magnesium need to meet only one oxygen. So the compound formula is MgO. Okay, another ionic compound. So these are all examples of ionic or electrovalent compounds. Okay. So now once we observe the ionic compounds, we can find that they are having certain uh, special properties. Okay. There is an activity given here. They are saying take salt samples like sodium chloride, potassium iodide, barium chloride, etc. in a spatula and heat it. Okay, so what they are saying is instead of melting, the color flame of the color will be changing according to the salt we are taking in. Okay, if it is sodium, it gives an orange yellow color, and if it is potassium iodide, it will give a violet color. If it is barium, it will give a green color to the flame. Okay, so it will not melt easily. Instead, it shows different colors according to the metal present. Okay, now they are saying make a circuit like this and insert the salt solutions and see whether the bulb is glowing. And if you try with sodium chloride, potassium iodide, barium chloride, or whatever ionic compound, the solution of that, we can see that the bulb is glowing due to the conduction of electricity through the liquid. Okay, so we can conclude the properties like this. Number one, physical nature. They are solids and hard due to. Okay, so they are solid, hard also. Okay, not soft at all, hard. And why? Because due to the strong force of attraction between the positive and negative ions. Okay, strong force of attraction, strong electrostatic force of attraction between the positive and negative ions. Okay, then they are brittle. We know if you break a sodium chloride crystal, it will break into pieces, isn't it? They are brittle. We call the property brittle. Unlike mud and all, it brittle. Okay, breaks into pieces. They are brittle. Then they are all having high melting and boiling points. In the previous activity, we saw that they, instead of melting, they are changing the color. That means they are having a very high melting point. Some values are given here. See, all it is nearly 1000 or above 1000. Okay, have very high values. It is showing at the melting and boiling point. Okay, so they are having high melting. Why? Due to the strong interionic attraction. They are attracted to each other so strongly, and it is we need a very large amount of energy or heat energy to break the attraction, force of attraction between the ions. So they shows a very high melting point. Okay, and they are soluble. Soluble where? Soluble in polar solvents like water. Okay, since they are ionic compound, they are having charged species in it. They are soluble in polar solvents like water and are insoluble in non-polar solvents like kerosene, petrol, etc. Okay, so if you drop a crystal of salt in coconut oil or in kerosene or petrol, it will remain as such. It will not dissolve. Okay, because they are all non-polar solvents. Whereas if you drop a crystal of salt in water, we can see that the very moment, next moment it will be dissolving, isn't it? So that is the difference. Okay, so polar solvent and a non-polar solvent. Now they conduct. We saw in the previous activity, they are conducting electricity. They are conducting electricity just because they have ions in them. The ions are present in their solutions and as well as in their molten form. Okay, and they are movable also, they are mobile also in molten state as well as in aqueous form. But solid ionic compounds do not conduct electricity because their ions are immovable. They are in a rigid state in the solid form. So they won't conduct electricity to in the solid form, but they will do or they will conduct electricity either in the molten form or in the aqueous form. Okay, and that's all about ionic compounds. Okay, we will see the more questions in the next video. Thank you.